Okay, let's look at the homework 3.7, problem number 1. Right, so we have an open box and the volume is limited to 32,000 cubic centimeters, and we want to find the dimension of the box that minimizes the amount of material used. All right, so let's do that. Alright, so here's the picture of the open box, and the base is x by x and the height is h. Alright, so let's express the volume. So volume V is x times h. So you have x squared h. Alright, so this is fixed to 32,000. Right? Then since we can solve for h, so I'm going to go ahead and do that. So divide through by x squared, and h is equal to 32,000 divided by x squared. So we have a way of rewriting h in terms of x, right? Then we have to find the area of the material. So A, all right, so area is going to be, all right, base is x by x, so x squared. And you have 4 walls, identical walls, so it's going to be 4 times xh. So each one has an area of x times h, right? So we want to minimize this guy, but before that we can just plug this in. So you have x squared plus 4x, then h is this guy right here. All right, 32,000 x squared. All right, so we can clean up. So let's see, there's an x on top, and one of the x cancel out. Right, so you will have, so this is going to be x squared. All right, plus, let's see, 4 times 2 is 8. 4 times 3 is 12. Then you have 3 zeros. And you have over x. All right, so we have that. And then we want to minimize this guy. So we want to minimize on, right? So restriction would be, let's see, x is going to be, you can, as long as it's not 0, it would be okay. If x is really small, we can make h large enough so that you get 32,000. So I guess x can go from, x has to be positive. Right, then x can be as large as we want. If you have a really big base, then you can make the height really small so that the still volume is that. So I guess it's going to go to positive infinity, right? So we want to minimize this function, right? So let's take the derivative to find the critical number. So this is a function of x. Right, so take the derivative of area function. You get, so derivative of this guy is 2x, right? And the derivative of this guy is going to be, let's see, negative 128,000 over x squared, right? Then this is equal to 0. All right, so then we can just add 128,000 over x squared to both sides. So you have 2x is equal to 128,000 over x squared. Right. Then we can just divide through by 2 first. Oh, actually, maybe I'm gonna just go ahead and then multiply by x squared, since I don't like fraction here. So you have a 2x cubed is equal to 128,000. Right, so I'm gonna go down here. Right, then divide through by 2. Right, so you get x cubed is equal to, so 64,000. No, actually, 64,000. Right. All right, so we take the cube root of this guy so that we can get rid of the cube. So x is equal to, right, 30 becomes 10. And the cube root of 64 is 4 times 4 times 4, so it's 40. All right, so 40 is this critical number. And just to make sure that this really gives you the smallest area, so we can just do the number line. All right, starting from 0. All right, so 40. All right, so we can just do something between 0 and 40, so like 1. So if you put 1 here and 2 minus a really big number, so it's going to be definitely negative. So negative here. All right, after 40, like 100. So you can see that 200 minus 100 squared will be 10,000. So that's going to be very small. So we know that's going to be positive. All right. So so a prime is that. So area function is decreasing before 40 and increasing after 40. So we know that we have the absolute minimum there, right? So critical number gives us the smallest area. So we know that x is going to be 40. So side of the base is 40, and which is actually given here. All right, height can be found. Remember, there's a formula here. There's a formula there. All right, so we have h is equal to 32,000 divided by, right, x is 40, so 40 squared is 1,600. So you can cancel 2 zeros, and the 32 have 2 16s, and there's 0, so there's 20, right, which is the correct answer. All right, that's it. I hope that this was clear.